Alright, welcome to Imlay City High School's chemistry. Today, what we're going to be looking at is a specific type of reaction called combustion. For combustion reactions, how do you know if a chemical reaction is combustion? Well, molecular oxygen gas is going to be a reactant, which means if it's a reactant, that means it's on the left side of your chemical equation. Remember, reactants are on the left side of the equation, products are on the right. So let's just go ahead and give you an example of a combustion reaction. CH4 gas is methane gas, and methane gas is the major component in natural gas, and natural gas is used by a lot of people for their furnaces and their hot water tanks. Obviously, it's used in the furnace to heat up the house. Obviously, it's used in the hot water tank to heat up water. But natural gas is about 80% methane. So when you combust or burn methane gas, that means it's going to react with oxygen gas. And we're going to make this a complete combustion reaction, because there's actually two general types of combustion reactions. There's complete and then there's incomplete. And in complete combustion, the amount of oxygen that we have present is in excess. Now, what that means is there's more than enough oxygen to go ahead and react with your methane gas. And if the oxygen gas is in excess in terms of the amount of it, the only products that you're going to produce here are carbon dioxide gas and water vapor. And obviously this is combustion, so it will be releasing heat energy. Remember that energy is the ability to do work, and work is having the ability to move a certain object a certain distance with a certain acceleration, and there is no chemical formula for that. So I just wrote down heat energy over there. Now, this is complete combustion. Now, we'll show an example of this. So let's just go ahead and write out a CH4 methane molecule, and then we're going to write in a whole bunch of oxygen molecules. And by the way, these are double bonds between the oxygen atoms that I'm showing there. So you're not going to get your methane to start reacting with your oxygen unless you put some energy into the system. In a furnace, it could be something as simple as a spark plug, or it could be something which we call a glow bar. Old furnaces, they actually use something called a standing pilot. But what that energy is going to do is, from the spark, it's going to break some of these chemical bonds between these atoms, and it's going to allow these things to start combining with each other and forming our products over here, and then it's going to release energy. And by the way, that minimum amount of energy that we need to get a reaction started, that's called E sub A, which is called the activation energy. So you can see here that we can have, let's say, these two oxygen atoms combine with this carbon to form our carbon dioxide. We could have, let's say, these two hydrogens combine with this oxygen to form our water, and we could have these two hydrogens combine with this oxygen to form more water. And notice that these oxygen molecules would just be bonded together, and we would have excess oxygen here. This oxygen did not actually go ahead and bond to any of the carbon or the hydrogen that was inside the methane. So this would be a complete combustion reaction. The reason why we call it complete is because all of the CH4 is completely turned into carbon dioxide gas and water, and those are the only two products. So in complete combustion, when you burn a hydrocarbon, your only products are going to be carbon dioxide and water. By the way, this chemical formula is not balanced. In a balanced chemical equation, that means we have the same number of atoms on the left-hand side as we do the right-hand side. Reason being is, in chemical reactions, we don't create atoms, we don't destroy atoms. By the way, this is the reason why the law of conservation of mass holds true, because if you're not creating atoms and you're not destroying them and you've got the same number of them, your mass before is going to equal your mass afterwards. So we've got, notice here we've got 4 hydrogen atoms here, whereas only 2 here on the right-hand side is products. So that means we need to put a 2 there. So that would give us 4 hydrogen atoms here. When we look at the oxygen, notice that we've got 2 oxygen atoms here, plus 2 more oxygen atoms here, which would give us 4. So we need to have 4 oxygen atoms here, so that would be 2. So what this means is that one CH4 is going to react with 2 oxygen molecules to go ahead and produce 1 carbon dioxide in 2 waters. And notice that's what we saw down here when we actually sketched it out. We had 1 CH4, which would be right here. Here's our 2 oxygen molecules right here. And here's the 1 carbon dioxide and the 2 waters that we actually made from that complete combustion reaction. Unfortunately, complete combustion is not something which is done by a household furnace or a household hot water tank that's using methane. By the way, when people burn propane, propane does basically the same thing. Propane is a very common thing to use. The chemical formula for propane is C3H8, and when propane goes ahead and reacts with oxygen gas in its complete combustion, you're going to produce the same products, carbon dioxide and water, and you're going to release heat. So it would basically do the same type of thing, give you the same types of products. All right, now let's go ahead and take a look at incomplete combustion. And an incomplete combustion, that's what cars are going to do, that's what furnaces are going to do. And an incomplete combustion, there's basically not enough oxygen gas to react with all of the other reactants. So, we can again use the same example. Here's our CH4 gas, again the major component in natural gas. It's going to be reacting with oxygen gas. This time though, the amount of oxygen here is limited. So what we're going to do now is we're going to draw out a whole bunch of methane molecules. And we're only going to draw out a few oxygen molecules. So again, we go ahead and we provide the activation energy, and we break these intramolecular chemical bonds, and then now we're able to start forming some new bonds between things. So what ends up happening is you can have some carbon here combining with your 2 oxygen molecules to turn into carbon dioxide gas, just like you had in complete combustion. You can have these 2 hydrogens combine, let's say, with this oxygen and form water. So water is also a product of incomplete combustion. And we could have, let's say, these 2 hydrogens combining with this oxygen to form more water for us. This carbon could combine with this oxygen. These 2 hydrogens could combine with this oxygen and again form more water. And notice that the carbon combining with this oxygen is going to lead to the formation of another product that we did not get in complete combustion, and that is carbon monoxide. And the interesting thing about carbon monoxide, it is known as the deadly silent killer, because there's no odor to it, and it's deadly. It actually asphyxiate people. The hemoglobin that's in your blood bonds to carbon monoxide actually better than oxygen. So rather than oxygen getting your cells to make ATP so that you guys can use as an energy source, the CO gets transported there, and your cells are going to run out of ATP and you die. So you can have that. If we had even some other CH4s here, and again our amount of oxygen is limited here, notice that there wouldn't be enough oxygen to go ahead and combine with the carbon and hydrogens here. So another product you can actually get from incomplete combustion is solid carbon. Now this is very important because a car actually runs off of incomplete combustion, a furnace does, and carbon, because it's a non-metal, does not conduct electricity very well, and this can actually build up on things like spark plugs, and this is why you have to change your spark plugs in a car, because with the carbon buildup that's on there, it can't spark and cannot ignite the gas for the car to basically run. Inside of a furnace, if you get the carbon buildup on a spark plug, it can do the same thing, and it's not going to be able to ignite the natural gas and create the fire and the heat that's going to heat up the home. So generally what you can do is you can replace a spark plug, or you can actually go ahead and take a piece of sandpaper when you remove it and sand off the carbon that's on there. So this is what incomplete combustion looks like. You've got carbon dioxide, water vapor, carbon monoxide, and carbon. And again, the carbon monoxide is a deadly lethal killer. So that's something that you don't want to have in your home. So let's go over to our furnace over here. And if we take the top door off of our furnace, actually the bottom door as well, you'll notice that right here in black we have our power venter motor. And what the power venter motor does is it pushes the carbon monoxide gas up these white PVC pipes and basically out of your home so that you don't die from carbon monoxide poisoning. Now, if you had water also flows in here, because you also have water created from the reaction, that's actually going to go ahead and drip outside out of the pipe when it condenses, and you can start to build an icicle out there. Now, if that icicle builds up, it can actually close up the pipe, and then you'd be getting deadly carbon monoxide building up in your house. So a safety feature of furnaces is that they have a shut-off if that gets blocked so that you don't die from carbon monoxide poisoning, and then the furnace would not operate. So the person would actually have no heat during the winter months, and it would be very simple. You'd go outside. If you saw that icicle, you'd knock it down. The vent would then be able to get rid of the carbon monoxide gas. You could turn the furnace back on, it would reset, and it would go ahead and work. You have the same thing if we look at our hot water tank here. The hot water tank, here's its power venter motor, and that's going to push the carbon monoxide gas, the carbon dioxide, and the water vapor that's created, and it's going to push that out of your house. Now, in older furnaces and hot water tanks, instead of using PVC pipe, they can use sheet metal. These are not high efficiency furnaces. And since that's got water in it, and it's exposed to the elements, that sheet metal can actually rust. It can get holes in it, and then you can get carbon monoxide leaks. So I definitely recommend, if you have a furnace like that, and if you have a sheet metal vent pipe that's got a whole bunch of holes in it, you're going to want to replace that. So we learned today about combustion. Again, it is when you take any chemical and react it with oxygen gas. We went over reacting oxygen gas with methane, but really combustion is reacting anything with O2 gas. Thank you, and we'll see you on the next episode.